Okay, now we're going to do number 57. It's 1 with adding. We have cubed root of 81x to the 12th plus 5 times the cubed root of 24x to the 7th minus the cubed root of 192x to the 4th. My goal is to get like terms under those radicals, and by that I mean, by terms I mean the number. I want the number under the radical to end up being the same, so I can combine those. So let's see what we can do here. Alright, let's start with these numbers. How can we write 81 as a product of something that is a perfect cube? We're going to go ahead and rewrite this as the cubed root of 27 times 3x to the 12th. Because 27 is a perfect cube. We're going to go ahead and rewrite the next term, as you guys could probably guess. Well, a factor of 24 that is a perfect cube is 8. 8 times 3 x to the 7th minus the cubed root of 64 times 3 x to the 4th. Oops, that's pretty bad. X to the 4th. 4. Okay, now here's my perfect cubes. I got one in every single house. Let's take them out. What's the cubed root of 27? Well, that's 3. So I got 3 times the cubed root of 3 x to the 12th plus, what's the cubed root of 8? Well, that's 2. So if I pull a 2 out over here, then I'll have 5 times 2, which becomes 10. 10 times the cubed root of 3x to the 7th minus, what's the cubed root of 64? Well, that's 4 times the cubed root of 3x to the 4th. Okay, now this is looking a little interesting because our cubed roots, oops, I meant to put a cubed root right there. Our cube roots also have these x raised to some power in them. They all look like they can be simplified, so let's see what we can do with this. They can be simplified at least some. Okay, I know here I can simplify that. X to the 12th, the cubed root of that is, you guys should know by now that what the guy in the ditch goes in the denominator. So if I have x to the 12th, how many perfect cubes do I have in there? Alright, I'm just going to do one so that we can see this. The cubed root of x to the 12th is the same thing as the cubed root of x cubed times x cubed times x cubed times x cubed. So I have 1, 2, 3, 4 perfect cubes in there, and every time I take out a perfect cube, I'm left with just an x. Take out another one, I'm left with just an x. Take the next one out, left with just an x. And the last one, I'm left with just an x. So I have 1, 2, 3, 4 x's there. So this term right here becomes x to the 4th on the outside, okay? So I'm going to undo this and just write an x to the 4. I'm going to rewrite this guy over here as x to the 4 on the outside. Alright, so that way it's not so messy, but you guys could see what was going on inside of there. It's going to take a second. Alright, so I have 3, and the x to the 12 just becomes an x to the 4 on the outside, times the cubed root of 3. This 4 is bad. Here we go. Plus 10 times the cubed root of 3x to the 7th. Well, x to the 7th is the same thing as x cubed times x cubed times x. So I have 2x cubes in there. I'm going to take out an x squared. Because every time I take an x cubed out of the cubed root, it becomes x. And I took out 2. And so the only thing that was left under there was 1 left over x, which is our remainder when we divide 7 by 3. So we have 10x squared times the cubed root of 3x minus 4 times the cubed root, well, let's look at this guy. Okay, minus 4 times the cubed root of 3x to the 4th. Well, x to the 4th, just a side note here, so you guys can see it again, x to the 4th is the same thing as x cubed times x to the 1st, which is just x. So there's my perfect cube. That's exactly what I'm going to pull outside of my radical over there, and it will just become x when it's outside. Okay, so let's do that. Once we pull out our x to the 4, we're left with just an x on the outside, and we're left with the 3x inside of our cubed root guy right there. This is pretty sloppy, sorry. It's a cubed root, so I'm left with x, just x on the outside, but then it's the cubed root of 3 times an x on the inside. So, this is also a cubed root. It looks sloppy. So where are my like terms? Well, this guy is the cubed root of 3x, and this guy is the cubed root of 3x. So it looks like I can maybe combine those. Yep. I don't know actually, because I got these variables over here. 10x squared minus 4x. I think I'm just going to leave this problem just as it is, because I don't want it to be too sloppy. I mean, if I really wanted to simplify it, I could have this be 3x to the 4th times the cubed root of 3 plus 10x squared minus 4x all times the cubed root of 3x. If you guys see where I got that, I just took that 10x squared and that negative 4x and put them right there, and they're both being multiplied by the cubed root of 3x. Ew, that's super messy. 3x, whatever. That's a 3x under there. And that is your final answer. The reason why I can't combine that 10x squared and that 4x is because those x's are being raised to different powers, and you cannot add unlike terms. So, both are a correct answer in this case.